Hello everyone. Today I want to quickly walk through the overall picture of web development that we've learned in this course. I've divided the entire field of web development into two main branches. The first branch is building blocks, which are the things we can see and interact with. The second branch is web architectures, which is the structure that supports all of this behind the scenes. Let's start with the first branch, building blocks. The foundation of all of this is HTML, which provides the structure. Its job is to define what content is actually on the page. We use tags like div and span to organize content, and meta tags to tell the browser some basic information about the page. Speaking of HTML, there are a couple of best practices that are important. First, for accessibility and search engine optimization, it's best to have only one H1 tag per page. Also, we shouldn't write JavaScript code in line with the HTML file. Instead, we should link to external JS files using the script src echo tag. This is cleaner and easier to maintain. Alright, now that we have the HTML skeleton, we need CSS to add style to it. CSS controls the layout and appearance. We use CSS selector to select the elements we want to style. For example, by ID, class, or using parent-child selectors for nested elements. At the core of our layout is the box model, which is margin, padding, and border. When writing CSS, we should try to avoid using bound important, because it breaks the cascading rules of CSS and makes maintenance difficult. Of course, if we don't want to write all the styles from scratch, we can use a framework like Bootstrap to quickly build a good-looking interface. Now, our page has structure and style, but it's still died. We need ESX or JavaScript to add interactivity to it. Before we start writing any real JS code, there's a very important rule. Don't start coding without ESLint and Praetor. These tools help us unify our code style and find potential errors, which is crucial in team collaboration. In ESX syntax, the first thing to remember is to use let and const to declare variables, and not to use var anymore. We use the function keyword or the more concise arrow function to define functionality. Modern JS development is modular. We use export in one file to export functions and import in another file to bring them in. To make the browser recognize the module syntax, we usually need to set type module, this, in our package.json file. When handling data, the most common data struct data structures we use are array and map. So, how does JS interact with the world? It has two main directly of interact. First, it needs to interact with the page itself, like DOM elements. We use methods like this: document.getElement by ID. Second, it needs to interact with the server to get data from the internet. For this, we use the fetch API to send HTTP requests. Because fetch is a network request, it doesn't return a result immediately. This means we have to deal with asynchronous programming. We no longer use old-fashioned callbacks. Instead, we use promise and more modern readable async and await syntax to handle these time-consuming operations. At this point, we cover the building blocks. We have HTML, CSS, and JS. These three together form what we call the front end. Now, let's look at the second main branch, web architectures. This is about how these building blocks are organized and delivered. First, the simplest architecture is static files. This is basically a pure front-end website, perhaps just HTML, CSS, and JS files. It can be deployed anywhere and can even work offline. But most modern applications are more complex than this. Let's look at a complete three-tier architecture, which is what we call full stack. The three tiers are client, backend, and database. Let's talk about the client first. This is usually the user's browser. The browser runs all the building blocks we just discussed. To make the user experience smoother, the browser uses Ajax technology. This allows it to dynamically refresh page content without reloading the entire page. So, who does the browser talk to? It communicates with the backend, which runs on an HTTP server. The technology stack we use to build this server is Node.js and the Express framework. Express helps us handle a lot of the low-level complexity. We just use app.listen to start the server and listen on our port, and then define various routes like app.get or app.post to tell the server what to do when it receives a specific request. The communication between the browser and the server must happen via HTTP requests. This is the common language between them. We have several core request verbs: get, post, put, delete. Get is used to retrieve data, post is for creating new data, put is for updating data, and delete is for deleting data. Finally, after the server processes a request, it often needs to interact with the database. A database is a tire to store data persistently. The database we are learning is MongoDB, which is a NoSQL database. How does our Node.js server talk to MongoDB? It needs to use a Mongo client. This client can come in several forms. It could be the official drivers that we install in our Node.js project to connect via code. It could be the Mongo shell that we use in the command line for testing, or it could be the graphical interface MongoDB Compass, which lets us see the data in our database more visually. So, to tie it all together, the browser sends an HTTP request like a GET or POST to our HTTP server, built with Node.js and Express. The server's routes receives the request, then might query the MongoDB database via the Mongo client, get the data, and finally send that data back to the browser. This is a complete picture of web development that we have learned. Hello everyone, for my deep dive presentation, I'm going to talk about a core concept in JavaScript called closures. We are going to explore this just by writing code step by step. To understand closures, we first need to understand a basic rule of JavaScript called lexical scope. Lexical scope. It's a straightforward idea. A function's ability to access variables is determined by where it is written in the code. Let's look at an example. A global variable and outer variable in function outer. And the inner variable in function inner. Inner can see its own variables. We print it. And then it can also see outer variables. And it can see global variables. Outer variable. Now let's call inner. in the function outer. And we call function outer in the global scope. So the inner function is written inside the outer function. This means inner has access to its own scope, inner scope. The scope of outer and the scope of global, the outer scope and the global scope. This is a rule. The inner function can look outwards. This is a foundation for closures. Now let's change this. What happens if the outer function returns the inner function instead of calling it? We define a new function called create greeters. And define a message hello. Hello. We don't call greet here, we return it. We call create greeter outside. At this point, create greeter has finished running. And my greeter is now the greet function. So what happens when we call my greeter? Let's try. Oh. As you can see, it still prints the hello message. This is a closure. Even though the create greeter function has finished, the my greeter function still remembers the message variable from its birthplace. A closure is this combination, the function and its memory of the variables from its original scope. So, why is this useful? The most common reason is to create private variables. also known as data encapsulation. Let's build a counter. This count variable is private. It's hidden inside this function's scope. We return an object with functions that can access and change count. Now we can increase function of increment and get value. Increment we print count number when we call increment. In the function getValue, we just return count. And for function createCounter, we could return two methods: add for increment and get for getValue. Now we can't access count directly from the outside. We can only interact with it through the functions we returned. We can create counter A and then call add. Or call get. Let's print the correct number. Each counter we create is separate and has its own private count. For example, we can create counter B. Counter A is still 2. Counter B is 1. This is a very common pattern. We used the closure to protect the count variable. The only way to change it is by using the add method we provided. This keeps our data safe and predictable. Finally, understanding closures is important for avoiding a very common problem, especially with loops. Let's say I want to print the number 0, 1, 2, 3, and 4 with a 1 second delay for each. The old buggy way to do this was with var. For example, for var set timeout runs a function after a delay. As you will see, it prints 5, 5, 5, 5, 5. Why? Because var is function scoped. There is only one I variable in total. The for loop finishes instantly, and I becomes 5. A 4 seconds later, when the set timeout functions finally run, they all look for I through their closure. They all find the same I, and its value is 5. The problem is now very easy to solve. We just use let instead of var. Let is block scoped. This means a new I variable is created for each loop. Each function closes over its own different I. Run it again. Now, you can see it prints 0, 1, 2, 3, 4 as expected. Because So, to summarize, a closure is not a complex thing. It's simple what happens when a function remembers the variables from the scope where it was created, even if it's called somewhere else. We use this for data encapsulation, and it's essential for understanding asynchronous code.